Well, we're going to start in with some trigonometry, and we're going to start with right triangle trigonometry. We'll be working from chapter 5 in your textbook. So this first little problem I have here, suppose you need to build a ramp to your house for wheelchair access. The porch is 30 inches from the ground. The angle the ramp forms with the ground, which is called the angle of elevation. So that angle of elevation would be this part right here. Can't be more than 10 degrees. What's the shortest ramp that you can build? So I want you to pause the video and think about it for just a minute. Think about where the parts would go. Where's the 30 inches? Where's the 10 degrees? What are we trying to find? So go ahead and pause that. I said pause it. Okay, so hopefully you did. So the 10 degrees is going to be this part right here. The 30 inches would be this portion here, and our ramp that we're trying to solve for would be this. I'm going to call it R. So when you think about how are you going to solve that, first of all, we have a right angle right here, and if you wanted to solve this, you would not be able to use the Pythagorean theorem because we only know one of the sides. So this is actually a problem that you would have to use trigonometry. So the trigonometric functions are defined in this way. The main three are called sine, cosine, and tangent. We abbreviate them. Do not call this sin theta. It is sine theta. Cosine theta, we use COS. Tangent theta, we use TAN. And to find those, now notice over in my picture here, we have angle theta is, oh, I did not mean to mark on that. But we have angle theta is marked. And so to find sine theta, you're taking opposite over hypotenuse, and it's opposite with respect to the angle. So if theta was up here, then this becomes the opposite side. So the opposite and adjacent are going to be in relation to wherever your angle is. However, the hypotenuse is always opposite the right angle. So sine, cosine, and tangent are our main three trig functions. The cosecant, secant, and cotangent are actually called reciprocal functions. So these are the reciprocal functions, and notice how sine is opposite over hypotenuse, so cosecant is hypotenuse over opposite. Now, we could write it this way. We could say that cosecant theta equals 1 over sine theta, because if you do the reciprocal of this, we could say secant theta equals 1 over cosine theta, and we could say cotangent theta equals 1 over tangent theta. So these are called reciprocal functions. This is the relationship. I know a lot of you would like it if sine could have gone along with secant because they both start with an S, and cosine and cosecant both start with a C, but it doesn't work that way, and there actually is a reason why, and we'll talk about it later. But you do need to know these relationships of these 6 trigonometric functions. So in this problem here, in this first example, we are going to find the exact values of the 6 trigonometric functions of theta. So when you're asked to do this, I would just start by writing sine theta, cosine theta, tangent theta, cosecant theta, and this will help you practice that too, secant theta, and cotangent theta. So to get sine theta, notice here is theta. So if you want to, you can mark these opposite, adjacent, hypotenuse, if that helps you. So sine is opposite over, oh, by the way, let me talk about this. And I know I had talked a little bit. Let's talk about Sohcahtoa. So opposite, oh, except I did that totally wrong. Oh, no, I didn't. Okay, redo. Okay, I'll rewrite it. Sorry about that. Sohcahtoa, I had it right. Opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. So that's just a little way to help you remember the trig functions. Okay, so sine theta is going to be 33 over 65. And if we could simplify that, we would, but 33, 3 and 11 are the only things that go into that, and neither one of those go into 65, so it can't be simplified. And so cosine is adjacent over hypotenuse, so we get 56 over 65. Tangent theta, opposite over adjacent, so we have 33 over 56. And then to get the reciprocal functions, we just flip these over. And I would leave them in proper fractions. And there we go. So those are the 6, those are exact values. Now, what's going to happen sometimes is you're going to have radicals in your answer. And so when it says find exact values, there are times where we will have those and we have to leave them in radical form. All right, so I want you to go ahead and pause the video and you are going to do this problem. Now remember, and I'll get you started on this first one, when you do sine theta, remember it's opposite, so the opposite is over here. So you're going to have, remember the hypotenuse is here. So when you write down 12 over 20, don't leave your answer like that because it can be simplified. So go ahead and simplify them. You're going to write this down. These are problems I'm going to be looking for on your notes. So when you submit your notes for credit for this assignment, then I'm going to be expecting to see these answers. So please just go ahead and do them. I'm going to show you the answers in just a minute, but pause the video, do the problem, and then we'll go, and then when you're done, go on and we'll check that. Okay, I'm getting ready to reveal the answers, so I hope you paused it and did it yourself. So, oh, it would help if I do that, right? Okay, so here are the answers to that. So you can go ahead and verify that that's what you got. Remember, I said you had to simplify those, okay? So, going on to the next problem. Actually, it's back to this problem. So let's go ahead and talk about, now, we actually now know enough information to solve this. So remember the 30 inches was here. We're solving for r, and this is 10 degrees. So if I wanted to know the value of r, how I'm going to do this problem is my angle is 10 degrees. I know relative to that angle, this is the opposite side, and this is the hypotenuse, which means if I write this as sine 10 degrees, I get opposite over hypotenuse, and now I can actually solve this. So the r is in the denominator, so keep in mind what you would really be doing. I'm going to multiply both sides by r, so it's out of the denominator, so it's off of that side. And now I'm going to divide by sine 10 degrees. So I'll grab my calculator here. So one of the things you want to make sure, but when we use our calculator, right now we're dealing with triangles, so we need to be in degrees. So if you hit the mode key on your calculator, you'll notice my calculator is in radians. I want to change that to degrees. There will be a time coming up soon where we will be working with radians, but right now we want to be in degrees. So that was, you hit the mode key, so you'll want to check that and verify you are in degrees. Now I can just take 30 divided by sine 10 degrees, and I'm in degrees, so I can just do sine 10. And when I do, I get this answer here. Let me fix this. Okay, so we end up with, and I didn't say anything to round to, but we get r is approximately 173 inches. Okay, I'm going to take this, and that's a little awkward, oh, let's make that ramp 173 inches. I would think it would be better to have something like 14.4 feet. So we could say r is about 14 feet. Let's be fancier. If I take this, I'm going to subtract the 14 to get rid of the 14 part of it. And this is a part of a foot. It's not a whole foot. It's less than a foot. I want to know how many inches that is. So I'm going to multiply this by 12. And I get about 5 inches. So let's say 14 feet, 5 inches would be the shortest ramp you could build according to code. So in this next example, if sine theta equals 1/3, find the exact values of the 5 remaining trig functions for the acute angle theta. When you have a problem like this, you are going to build a triangle. And it's a generic triangle, so it doesn't really matter. It doesn't have to be perfect. Make sure it's a right triangle, and then pick where you put theta. And I tend to, all my triangles look the same. They all look like this. So yours probably will too. Anyway, so if this is where I place theta, then this would be the opposite. This would be the hypotenuse. So now I have my opposite and my hypotenuse placed. Now, keep in mind, this could be 10 and 30. So we don't really know. We just know the ratio of the sides is 1 to 3. So we're going to use that because that's all we need to know. But I have to figure out the other side. And we didn't review this. We probably would have if we had been having class. You're going to need to use Pythagorean theorem to find the other side. So hopefully you guys all know that. A squared plus b squared equals c squared. Well, in this case, we know the c squared and one of the sides. So if we want to find the other side, to find the missing side, we're going to take 3 squared minus 1 squared. So 9 minus 1 is 8. So this side right here is the square root of 8. But that's not simplified form. So remember, you can break that down. The square root of 8, you can think of as the square root of 4 times the square root of 2, which is 2 root 2. So we should think of this as 2 root 2. This is all the preliminary work that you have to do before you actually get started writing out your ratios. So we already have sine. I'm going to list it anyway. Well, that was awkward. So we have sine theta is 1/3. We already know that. We need cosine theta. We need tangent theta. We need cosecant theta. We need secant theta. We need cotangent theta. So cosine theta is going to be 2 root 2 over 3 because it's adjacent over hypotenuse. So we get 2 root 2 over 3. Tangent theta is opposite over adjacent. So it's 1 over 2 root 2. Okay. Uh-oh. We're not supposed to leave a radical in the denominator. So I keep going up to these because the line's too thick and I can't make it default to the smaller line. So in case you wonder. I have to multiply the top and bottom by the square root of 2. And when I do that, I'm going to get the square root of 2. And in the bottom, remember root 2 times root 2 is just 2. But I already had a 2 there, so I get a 4. This is simplified form. Now I'm probably going to be a little lenient if you leave it in this format. But I would like you to try to put it in the best form. All right. So cosecant, we're just going to flip it over. So 3 over 1, which I can just write as 3. This is going to be 3 over 2 root 2. Uh-oh, so we're going to have to multiply. And we get 3 root 2 over 4. And for cotangent, when you flip it over, don't flip over what we got here. Flip over what we had originally. So we get 2 root 2 over 1, or I can just write that as 2 root 2, because then otherwise you would be flipping it and then simplifying it again, rationalizing the denominator. So that's what, it's worth writing that down. So those would be all of my answers. And here is a practice problem for you. So go ahead and set this problem up. Now I'm going to help you with the triangle, but then you're going to come up with the 6 trig ratios. You're going to pause this after I set it up, help you set it up. And then remember, I'm going to be looking for this example on your notes especially. So when you draw this triangle, and like I said, they all look the same. Tangent is opposite over adjacent. So I'm going to have a 2 here and a 3 here. You're going to have to solve the right triangle with Pythagorean theorem. You're going to have to solve for the hypotenuse first, and then set up your 6 trig functions. So pause it and do it. Okay, I'm getting ready to reveal the answer, so I hope you worked it out. Here are the answers that you should have gotten. I'll be honest, I have not vetted out these answers here to work them out. So you'll have to let me know if there's a problem on one of these because I didn't work these out. So anyway, so hopefully you are good on a problem like that. Okay, next thing, trig values for special angles. So let's work with these two special triangles. And you might remember having done these from geometry because you did do them. So we have a 30, 60, 90 triangle, which is a very special right triangle, 45, 45, 90 triangle, again, a special right triangle. What makes these so special is the relationships of the sides. And we would have done a really cool activity in class, but we don't get to do that because we're not in class. So instead, I am just going to tell you what the relationship is, which is just not nearly as good as doing a cool activity, but it is what it is. So the ratio of the sides for 30, 60, 90 is 1 to square root of 3. And so if this side were 1, the hypotenuse is always going to be double whatever the shortest side is. Whatever the shortest side is, this side right here is always going to be the square root of 3 times whatever that side was. So that's the relationship that you need to remember. For a 45, 45, 90 triangle, the relationship is this. If this side is 1, then this side is 1 because it's an isosceles right triangle. And this side would be the square root of 2. So that's the relationship of the sides. So what that means, for example, let's say I had a 30, 60, 90 triangle. So say this was 30 and this was 60. And then if I knew that this was, say, 3, if this side length was 3, then I would know right away that this is double that. So this would be 6, and this would be 3 root 3. So that's what that means. Okay, so that's what would happen there. If for a 45, 45, 90 triangle, if this side, well, let's do this. If this side was 5, I'm going the other way now. So this one, if I would have multiplied by the square root of 2 to get to this direction. So this would be 5 divided by the square root of 2 because I'd be going the other way, which of course I would say is 5 root 2 over 2, which this would be the same thing. Once I solve for one of them, I can do the other. Maybe I shouldn't have done that one first, but okay, I'll give you another one. If this had been 3, then this would be 3, and this would be 3 root 2. So it's definitely easier to go that direction. If you're going the other direction, you just have to divide instead. But we're going to do the trig values for these angles. So I'm going to erase all of that I just did. Of course, you could always rewind if you wanted to watch it again. So let's write these out. So we have, for the 30, 60, 90, we get sine, we're going to have sine 30 degrees, and we have cosine 30 degrees. I'm just going to do these main 3, and tangent 30 degrees. And then we're going to have sine 60 degrees, cosine 60 degrees, and tangent 60 degrees. And then we'll have sine 45 degrees, cosine 45 degrees, and tangent 45 degrees. Okay, so here, sine 30 degrees, we're going to take opposite over hypotenuse, we get 1/2. For cosine 30 degrees, we take adjacent over hypotenuse, we get root 3 over 2. For tangent 30 degrees, we take opposite over adjacent, we get 1 over root 3, which when we rationalize the denominator, we get root 3 over 3. Sine of 60 degrees, notice now we're at this angle. We have to take opposite over hypotenuse. So opposite the 60 is the square root of 3. Over the hypotenuse is 2. Cosine of 60 is adjacent, which is 1 over the hypotenuse, so 1/2. Tangent 60 degrees is opposite, which is square root of 3 over adjacent, so square root of 3 over 1, or just square root of 3. Sine of 45 degrees is, and it doesn't matter which one you're at because they're both 45. So we have opposite over hypotenuse, so 1 over root 2, which rationalizes to root 2 over 2. Cosine 40 degrees, adjacent over hypotenuse, you get the same thing, 1 over root 2. So root 2 over 2. And for tangent 45 degrees, you get opposite over adjacent, 1 over 1, which is 1. These are important. Very, very important. So much so that you have to memorize them. You have to know these. So what you want to memorize is the relationship of the right triangles so that you have all of these memorized. It is crucial for those of you that will take calculus either in college or next year in high school. If you plan to take calculus, you must have these exact values memorized. So you want to work on that. Okay, I can't pause the video, so isn't that interesting? Here is a chart of all those values. So that also means I'm not going to be able to stop the video. Oh, okay, it worked. If you caught me saying that, I almost said I wouldn't be able to stop the video, which means I would just have to do this for the next 3 weeks. Just kidding. Okay, so we have the 30, 60, 90 triangle. Now, instead of labeling them, they labeled these a little different. Notice instead of 1, like this could be 1, 2, square root of 3. The way they have them labeled, so it doesn't matter like if this was a number like 5, then this would be 5 root 3 and this would be 10. So it's still the same relationship. But you see not only the sine, cosine, and tangent values, you also see cosecant, secant, and cotangent on this. So, you know, you can, I'm really sorry I didn't give you guys a handout of this that you could have been writing the notes on, but I didn't have time to know everything I was going to be doing. And so sorry about that, but you can get this information, maybe screenshot this or something if you want to, and then and have a copy of it. It's in your textbook too. Okay, so let's look at this example. Find the value of x, round to the nearest tenth if necessary. So this is similar to the problem I did on with the ramp, for the handicap ramp. So you want to just pay attention to what do I know. So my angle 35, which is actually this angle up here, I know the adjacent side, and I know, or I want to know the adjacent side and the hypotenuse. So you have to think about what trig ratio deals with adjacent and hypotenuse. Well, that's cosine. So cosine of 35 degrees equals adjacent over hypotenuse, and we solve that. So we get x equals 7 times cosine of 35 degrees. And when you check that value, you get x is approximately, says round to the nearest tenth if necessary, so we get 5.7. We don't have any units. If we did, we would put them. Okay, so there is that problem. And you are going to go ahead and try this one. So go ahead and pause it and give this one a try. So did you get it? Do you have the answer? Yeah, too bad I can't like call on somebody or pick a popsicle stick or whatever. But you should have gotten rounded to the nearest tenth. You should have gotten D. What you're going to do is you identify opposite over hypotenuse. So that tells you should be using sine. And we get 7 over x. So on this one, this is one where you have to kind of do this a little bit of math here because you're going to cancel that out. So we get x equals 7 over sine 41. And that's what you're going to evaluate and round it to the nearest tenth. You get that answer. The last example is solving the right triangle. What that means is you have to find all the missing parts. So when you are asked to solve a right triangle, you need to find whatever's missing and round to the nearest tenth for any parts that, when you need to. So first of all, I know that this is a 90-degree angle. I know this is 70 degrees. You better be able to find this angle, because if you don't know it, I'm going to go tell Miss Yoder on you, because she would expect you to remember the sum of the angle of any triangle is, go ahead and say it. Very good, 180 degrees. Oh, I'm probably sounding like that guy on that conic section video that I made you watch. Anyway, so we end up with 20 degrees here. So we find that. So now that's one of them. We got the angle. Now we have to find the missing sides. So it doesn't really matter which you pick. I'm going to use the 70 degrees. And I'm going to call this X and this Y just for convenience. So labeling them, this is horizontal, this is vertical. So that makes sense to me. And then I'm going to use, obviously I wouldn't want to use tangent. I'm going to use sine and say that sine 70 degrees equals x over 15. So then x is 15 sine 70. So 15 sine 70, we get x is approximately 14.1. And if you're going to call it, label it something, make sure your picture's labeled so that I know what you're talking about. Here was one of our answers too. And then to get the y value, I'm going to use cosine of 70 degrees equals y over 15, adjacent over hypotenuse. So we get y equals 15 cosine 70 degrees. So we have y is approximately 5.1. Okay, that takes us through, don't have a practice problem on this one, that takes us through the first day of notes. And I'm going to expect you to show me your notes, so you're going to have to somehow manage to get that information to me and turned in Google Classroom. And I will be posting the assignment that goes along with this tomorrow.